Finally, time for some doom scrolling.
Tung 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 sahur.
Napierdolę się, jak
Z truskawkami, pekotka.
Pisi pisi. Miau miau. Wow. Watermelonini cetu pisini.
Never use a Pioneer mixer. It is very disrespectful to run Technics turntables through a Pioneer mixer. Here's why. Pioneer mixers do not have true RIAA correction on the phono preamps, resulting in a muddy sound from your vinyl and more prone to causing feedback due to a 70 Hz wideband boost and greater than 12 kHz roll-off. Did Pioneer do this on purpose since the early 2000s to cause problems making people go digital and take over the market with their CDJs? Most engineers would say yes, and can give no logical reason other than sabotage of vinyl use, which is disrespectful. Stick with other brands, because if even the cheapest brands can get this right, then something is seriously wrong with Pioneer DJ Alpha Theta. Therefore, when choosing a mixer, make sure you take advice from engineers, not influencers.
So this image talks about a problem, but there is no data, no measurements to back it up. I was digging deeper and this serviceman published a PDF that is an extension for this image. I don't want to read 2 pages right now. I will link this in description if you are curious. But yeah, the author of this document is Mr. Richard. He's a qualified service engineer from UK, and he warns us that Pioneer mixers don't reproduce vinyl in correct way, that the RIAA curve is not applied in a correct way. He tells us that there is a problem with this wideband boost, roll-off, and he just speaks about the need of using RIAA curve. He's even warning us that when using Pioneer mixers, there's a risk of hearing damage. And also he asks us to beware of social media influencers and famous DJs who would say otherwise. Unfortunately, there is just no data to back those words up. I'm not I'm not sure how people believe this, if it's just said and not backed up, but why not doing this? Let's do those measurements. I'm not a social media influencer yet, I'm not a famous DJ yet, I'm just a humble engineer, so maybe I can try my best and investigate. So let's go! To be sure that the problem you speak about was present during the years, I've prepared a good old DJM 600 mixer, which is analog by the way. Digital processing is done in the FX section, phono amplification and EQ are analog here. Then we will test more recent model, DJM 900 Nexus. This is a digital mixer. Phono preamp is hybrid here. There is a low noise analog frontend that boosts the phono signal without equalization, then signal gets digitized and RIAA correction is applied in digital domain. I've also prepared Xone 92 to see how it performs compared to the Pioneer. Also, thanks to my friend, I'm able to measure good quality phono preamps from Sheet Company. Those are hi-fi phono preamps, not DJ stuff. It will be interesting to see how they behave in comparison. The measurement gear will allow us to do this test using 2 methods. First obvious method will be generating the signal with inverse RIAA curve to see if the measured phono preamp will turn the curve flat thanks to the onboard RIAA equalizer. Second method will be more true to what's really going on. Thanks to Unitra company, I'm able to play a test sweep using a test record and a turntable, and here's where we'll become really close to the truth. To show respect to the Technics brand, I used a reloop turntable next to a Pioneer mixer. Alright, so let's analyze our results using method 1. So I was generating the signal with audio interface. So this red curve we see here is is the signal, is a frequency response of a signal that we feed phono inputs with. So this is the frequency response of our test signal, is reverse RIAA curve. Then, hypothetically, our devices, our measured devices, should have a RIAA response. So this is a hypothetical response of our measured device. And here, those pretty flat curves we see are the responses of our measured phono preamps, and they also they just show us deviation from the RIAA curve. So if we get it perfectly flat, that means that our phono preamp has ideal response sticking to the RIAA curve. So let's take a look first at hi-fi phono preamps. Let's exclude the DJ preamps and let's see how sheet money and sheet skull behaved. Let's zoom it a bit to get good accuracy. So yeah, we can assume that sheet preamps are really flat and they are really true to the RIAA curve. The deviation here, I see that the deviation is within half dB. So it's really precise. Half dB deviation is something we can barely hear. So we can assume that both sheet preamps are really reference grade in terms of RIAA response. And now let's take a look at DJ mixers. 3 at the time. Oh. It's not so flat in 3 cases. In case of Pioneer, in case of both Pioneers, and in case of Xone, the responses are not very flat. I will turn off the responses of hi-fi phono preamps and let's analyze the DJ mixer responses. So first we see that every DJ mixer I measured has this low frequency roll-off, and I think it's generally good. I think that this low frequency roll-off in terms of clap environment is good. Sometimes manufacturers do this on purpose. They put subsonic filters to filter out the lowest frequencies, and sometimes the cutoff frequencies of subsonic filters cutoff frequencies are set in the audible range. It starts to roll off well before above 20 Hz. So here the 2 ugliest responses that are not sticking to flat responses are DJM 600. We get this high frequency roll off here. It's not super dramatic because it's like 1.5 dB. It's not super dramatic, but it's not perfect. And here the blue curve is Xone 92, and here we see some also not dramatic deviation, but it's about 1 dB boost. 1 dB boost in high frequencies. And Pioneer DJM 900 is the most flat. When we are checking this PDF document from the serviceman, he highlighted 2 issues. First issue was some dramatic roll-off above 12 kHz. I don't see it. DJM 600 has some roll-off, but it's not a dramatic one. DJM 900 is really, we can consider it as really flat. And Xone has this nasty boost, so in terms of being faithful to RIAA reproduction curve, I guess that Xone does not win here. And another thing that was mentioned in this picture was wideband boost in low frequency region. This boost I think we can ignore. This is like, you know, like 2/10 of dB. This can be considered as a major boost. And in 2 other cases, in case of Xone and in case of Pioneer, we get this low frequency roll-off. No boost in a low frequency region. So this info about boost was just made up. And this info about roll-off was also made up. but as I said, those measurements we made here with audio interface are like synthetic ones, because we don't see how the phono preamp interacts with phono cartridge. Here we just applied a synthetically generated signal with an audio interface and just run it through the phono preamp. So this doesn't show us the full image. So let's not assume anything at this point. We have a clue what's going on, and I think that so far the news are good for Pioneer. It remains just flat. It's nothing dramatic happening here, but let's test it with a test record. I will use 20 Hz to 20 kHz sweep from a test record. Thanks to this, we will be able to see how phono cartridges interact with input capacitance of phono preamps. This can affect the final response significantly. I will not only measure the mixers. I was curious how frequency responses of free cartridges will look like, and how will they change when messing with input capacitance values that can be changed in sheet preamps. Okay, so let's do this. First, let's analyze frequency response of three different phono cartridges. I have a Hi-Fi cartridge from Audio-Technica brand, Orthophone Club MK2, and legendary Shure M44-7. And those are the responses. Let's take a look at all of them with one given capacitance value to compare it in the same conditions. I measured all the cartridges using sheet preamps because they have flat RIAA response, so I wanted to stay as close to the flat response as possible. So let's check Orthophone, M44 and Audio-Technica with 200 picofarad input capacitance. The cartridge responses are pretty similar, but we see that the biggest difference is in the high frequencies. And this is where the interaction, the phono cartridge and phono input interaction starts to count. When we are using the first method, when we are measuring phono preamps with audio interface, with synthetic source, we were unable to see such stuff. So yeah, here we can see that M44 has the biggest boost in high frequency region. Other cartridges are flatter. Here we have kind of dip that differs for three different cartridges. And here, interesting thing is that Orthophone Club, I don't know what it is. It doesn't appear on other cartridges, but it has some kind of resonance here, I guess. Other cartridges remain flat. So this Club cartridge has some nasty resonance. And so yeah, we can assume that the frequency responses of cartridges are pretty similar, but they are not the same. So, long story short, sound depends on cartridge used. And now let's observe how capacitance affects, input capacitance affects frequency responses. So first let's analyze what happens when we raise input capacitance from 50 picofarads to 200 picofarads in each cases. So in Orthophone, it changes high frequency response a bit. It's not dramatic. It's a slight change. We can zoom it. It's a slight change, but I guess it can be heard. Now Audio-Technica, 50 picofarads, 200 picofarads. And Shure M44, 50 picofarads, 200 picofarads. Here the change is the slightest, so it's not very sensitive to capacitance change, at least in this region, but we see in all cartridges the same behavior, that raising the input capacitance causes earlier high frequency roll-off. And here I also prepared a dramatic example, and it was done in Rodec mixers. There is a mistake in Rodec mixer design. In MX180 MK3 model, by accident they placed 1 nanofarad, so 1000 picofarads of input capacitance, and it has really dramatic, it affects the frequency response dramatically. Here we have two responses of M44, 50 picofarads and 200 picofarads, and let's see what happens when we add 1000 picofarads. So we raise input capacitance dramatically. Do you see this? 1000 picofarads causes serious roll-off. So we lose a lot of high frequency content. So this is just too much. So we can assume that changing input capacitance give us a slight change, but the real problem starts to arise when we put way too much capacitance. 1000 picofarad is way too much. Ladies and gentlemen, we did it. We measured mixers with a test record, so we are very close to the truth. I hope. So yeah, I've measured 4 devices, 4 mixers, 2 mixers from Allen and Heath, because I had also Xone 62 at home, so I've measured 62 and 92. From Pioneer I measured DJM 600 and 900, and I've also measured sheet skull, hi-fi preamp. All the measurements were done using orthophone clap cartridge, and sheet skull has 200 picofarad of input capacitance. Mixers didn't have ability to set input capacitance, so it's just a mixer's input capacitance. So yeah, the first thing I see here is that hi-fi preamp sheet skull is the flattest one in high frequency region. What I mean by saying the flattest, it doesn't have any significant high frequency boost. It's pretty flat. All other mixers have boost, bigger or smaller, but have boost in high frequencies, and yeah, the boosts are pretty similar. Speaking of lower frequencies, here on Xone 62, the bass is a bit attenuated. There is a small deviation, but yeah, more or less other mixers are pretty much the same. And referring to the PDF we are still talking about, or this image from a serviceman from UK, we should seek for 70 Hz wideband boost. So I don't see any boost here. even for Pioneer mixer. No boost here, I'm sorry. And also roll-off above 12 kilohertz. So let's see, 12 kilohertz roll-off. I guess all the mixers are rolling off above 12 kilohertz, and this is quite normal behavior, so I wouldn't blame Pioneer. I would just blame vinyl for this. And yeah, so let's have a look at the mixers separately. This is Xone 92, this is Xone 62, this is DJM 600, and this is DJM 900. So what I notice is that DJM 900 seem to roll off a bit earlier than other mixers, but when you analyze how dramatic this roll-off is, it actually turns out that it's not very dramatic. When we consider this level here as flat, let's see what's the minus 3 dB drop. 87. So minus 3 dB drop for Pioneer DJM 900 for high frequencies will be at 15 kilohertz. So yeah, other mixers have this drop somewhere a bit far away. So yeah, we can say that DJM 900 is rolling off a bit earlier. I am curious what's the reason, if it's inappropriate input capacitance or some other reason, but I wouldn't say that Pioneer is far away from RIAA. It's pretty similar to what's going on in other mixers. In DJM 600 is totally similar in terms when we compare, for example, Xone 62 and DJM 600. They are almost the same in high frequency region. In low frequency region, Xone 62 has a bit less bass, yeah, here. But yeah, nothing dramatic here. So let me know what you think about this. I guess I did everything right, I hope. That's all I could show to you. If I made some mistakes and I didn't resolve any mystery, please let me know. I also hope that the author of the PDF and image, Serviceman from UK, will share some insight and measurements. Maybe this is not the end of discussion. But yeah, those are my 2 cents. Thank you for watching. I hope it clarifies something. I personally, I will not blame Pioneer for ruining the vinyl market. I will still place Technics turntable close to Pioneer mixer without any feeling of disrespect. But maybe I'm wrong. Please let me know. Thank you. Bye.